Colossal asteroid impact forever changed the balance of our Earth's moon. And you'll also see some images from NASA, far side of the moon, what looks like various strange artifacts. Who put them there? Especially a rod horizontally across a crater. Very strange. But anyway, going back to this, an ancient collision is to blame for all the holes, quote unquote, on the far side, what we call the dark side of the moon. One side of the moon is littered with far more craters than the other, and researchers finally know why. The massive asteroid that slammed into the moon around 4.3 billion years ago wreaked havoc in the moon's mantle, according to a new study. More than 9,000 visible craters pockmark the moon, potmark, I would say, the moon, thanks to a barrage of impacts from meteors, asteroids, and comets over billions of years, according to the International Astronomical Union. However, these craters are not evenly distributed across the lunar surface. The far side of the moon, which people never see from our Earth, because the moon is tidally locked, meaning that it takes the same amount of time for the moon to rotate and orbit the Earth, has a considerably higher concentration of craters than the visible near side that we see. Okay, so it has the far side has a higher concentration of craters than what we see. The near side of the moon has fewer pits because the surface is covered in lunar maria, vast stretches of solid lava that we can see with the naked eye on Earth as dark patches on the moon. These lava fields likely covered up the craters that would otherwise have marked the moon's near side, and the far side of the moon has almost no lunar maria, which is why its craters are still visible. This is what the scientists are telling us. Scientists have long suspected that lunar maria formed in the wake of a massive collision around 4.3 billion years ago. The collision created the South Pole, Aitken Basin, SPA, a huge crater with a maximum width of around 1,600 miles, that's 2,574 kilometers, and a maximum depth of 5.1 miles, that's 8.2 kilometers, which is the largest pit on the moon and the second largest confirmed impact crater in the solar system. However, until now, researchers were unable to explain why only the near side of the moon has lava fields. Now, from the images I've seen of the near side and the far side, it does look that there is soil on the far side as well, what they call maria. I don't know if the depth is different. But anyway, going back to this, the new study finds that SPA impact created a unique phenomenon inside the moon's mantle, the layer of magma below the crust that affected only the near side. We know that big impacts like the one that formed SPA would create a lot of heat. This is what lead author Matt Jones said. He's a doctoral student of planetary science at Brown University. He said the question is how that heat affects the moon's interior dynamics. Researchers already knew the near side's lava fields originated with the moon's mantle because lunar samples brought back by Apollo missions contained radioactive heat-generated elements such as potassium, phosphorus, and thorium that are all suspected to be found in abundance within the lunar mantle, according to their statement. In the new study, computer simulations revealed that the SPA impact would have created a heat plume within the mantle that pushed the radioactive elements towards the crust. The researchers repeated the simulation for a number of possible scenarios of the SPA impact, including direct hits and glancing blows, and found that regardless of how the asteroid hit, the mantle impacts would have only affected the near side of the moon. Put another way, when a space rock collided with the moon, it caused lava from the mantle to pour out on the near side, that is the opposite side from where the asteroid hit, burying many of its older impact craters. Quote, what we show is that under any plausible conditions at the time that SPA formed, it ended up concentrating these heat-producing elements on the near side, Jones said. We expect that this contributed to the mantle melting that produced the lava flows we see on the surface, he said. The researchers are pleased to have solved what they described as one of the most significant questions in lunar science, according to their statement. The SPA impact is one of the most significant events in lunar history, Jones said. Being able to better understand how it shaped the two sides of the moon we see today is really exciting, he said. This has been published April 8th in the journal Science Advances, originally on Life Science, by Harry Baker. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.